You know what I've discovered after, like, I went back and watched, like, some of the recordings that I've done in years past. And this is what I found out. I start every recording the same exact way. I always say, all right, and then I start teaching. All right, so yesterday you guys did section 1, 2. We started 1, 2, 1, 3. Today we'll finish, like we did the 1, 2 part of it. We'll do 1, 3 today. Should be really simple. And then at the end of class, what we'll do is we'll work on the remaining problems on this worksheet. And then you guys have a long weekend. You have Monday off. That's kind of nice. So when we come back on Tuesday, I will give you a review over sections 1, 1, 1, 2, and 1, 3, which means on Wednesday, what? Yes, wear pink and take the quiz. Yep. So on Wednesday, you guys will take a quiz on 1, 1 to 1, 3, and then we'll move on after that. Okay, sound good? Yay. All right, cool. All right, so we talked about midpoint formula yesterday. We talked about finding midpoint between 2 points. And then we also looked at some where we give you a midpoint, we give you an endpoint. We have to be careful with those ones. So we'll start with number 5. Who did number 5? Sam. All right, cool. So we've got 1, -6, and then 10, -5. Tell us what you did.
Added the 10 and the 1 and then divided by 2.
Yep.
And then -6 minus 5 divided by 2.
Good. Cool. So you add your x's together, add your y's together, divide each by 2, 5.5, -5.5. Sounds good to me. Cool. Who did number 6? All right, Alex. -5, -2, 1, 2. Tell us what you did.
Added my x's, added my y's, divided them by 2.
Cool. So -5 plus 1 gives us -4. Half of -4 would give us -2. So that x coordinate would be negative. And then when you do 2 and -2, that's just 0. And half of 0 is 0. So our coordinate point would be -2, 0 is what we should have. Okay, cool. Good job. Now, 7 and 8, we have to be really careful. Who did 7 and who did 8? Alina and Kenzie. You did 8, and then Kenzie, you did 7. I like how you guys did those problems. I like how you drew like a little number line and then put your points in there. That's really how we should do it, okay? So when we look at Kenz's problem, they tell you that an endpoint is 8, -7, and that a midpoint is 1, -6, okay? Now, what I would prefer to see you guys do is put your, if you put them on a number line like this, put them in order from least to greatest. So for example, we know that this is the midpoint, but 8, -7 is an endpoint. Since we read math the same way we read the English language, which is left to right, 8, -7 would actually come after 1, -6 because 8 is bigger than 1. So I would rather see you put 8, -7 here. But I think Ken still gets the same answer. So Ken, you notice the difference between 8 and 1. What did you have to do? Yeah, so then you're going to have to subtract 7 from 1, which is going to give you -6. So that's still the right answer. That's good. And then for your y values, what did you have to do for your y values? Good. So then -6 plus 1 gave you -5. That's perfect. So your answer looks really good. Good job. And then Alina, you did number 8. Yours looks great. 2, 3 all the way to the left. That's the order that they gave you, and ended up that's the perfect order to have. Midpoint was 6, -2. What was your difference for your x values? Good. So I gave you an x value of 10. And then for your y values?
Subtracted 6.
Nice. So then you ended up with 10, -8 as an answer. That looks perfect. Great job. Cool. Number 9. So with number 9, now we get into a graph. We didn't really talk about how to do the ones with the graph. Who did number 9? Oliver. All right, Oliver. What did you do with the graph to come up with those values? What did you do there? Yeah, I asked the question in a really weird way. So let me try this again. How did you come up with those numbers?
Okay, so I put the points and then used the what's it called, the formula from the notes.
Yeah.
And just solved it like that.
Good. So you just picked out the points on the graph, and then you just wrote them as coordinate points, right? And then did midpoint formula with it. I asked it in a weird way. Okay. So then your coordinate points were -5, 5, and then your other point was, it actually should be 3, 0 instead of 3, 1. So I'm going to change that real quick because it hits right on that x-axis. So your y value there would be 0. So 3, 0 is the value that we're going to use. So it's going to change things just a little bit, but not much. Okay. All right. So then Oliver does, adds his x's and divides by 2. So 3 plus -5 divided by 2 gave him -2 divided by 2 is -1. That's good. And then the y values would be 0 plus 5, which is 5. And what's half of 5, Oliver? Yeah, so we would say -1, 2.5. Now, I do want to see parentheses there. So make sure you put parentheses when you write your answer as well, too. It's all good. Cool. Good job. All right, and then we started getting into some number line stuff in segment addition postulate. Who did number 10? All right, Parker, what did you do? I want to come up with the length of UV. What'd you do?
UV is, all right, the entire thing's 23.
Yep.
Minus 11 is 12.
Cool. So I know the whole thing's 23. So he just did it without writing letters. He didn't really need to. Yeah, so it looks good. So I ended up with 12. Good job. Now, if I wanted to get crazy, I would say something to the effect of like UV plus VW equals UW, and then I'd put in the values that I know. So I don't know what UV is, but I know that VW is 11 and UW is 23, and then I would subtract 11 from both sides, and that is another clean way to get it that it's 12. But Parker's right. The answer's 12. Good job, bud. All right, number 11. Who did number 11? All right, Carter. Now we got some x's in this one, right? So we got to set up an equation and then solve some variable stuff. So what'd you do?
I did 8 plus 2x plus 18 equals 8 plus 8, x plus 18.
Mm-hmm.
And then I combined like terms, and then after that I subtracted x from both sides and then 26 from both sides to give me x equals -8.
Cool. Nice job. Now, I think it does ask you to find the length of your segment, right? No, it just says solve for x. Never mind. Now, isn't it weird getting like x equals a negative number in a situation like this? Because we need all of our segment lengths to be positive. But here's the thing. It just says x is negative. It doesn't say a segment like this positive. So let's plug in -8 as an answer and see what we get. So what's 2 times -8? Like if I plug it in, what would be 2 times negative? -16. And then -16 plus 18 would be what? So then that gives us a segment length here of 2, which in context makes sense because this whole thing is 8 and this whole thing is 2. And then if I plug in -8 into this expression, -8 plus 18 is going to give me what?
10.
Nice. So then the whole length is 10, 8 and 2 is 10. Everything's making sense. Okay? Does that make sense? Number 12. Who did number 12? All right, Emma. Okay, so we've got more stuff with variables. This is 10. This is x plus 1. The whole thing's 2x. What equation did you set up?
I did 10 plus x plus 1 equals 2x.
Okay.
And then combined my terms.
Mm-hmm.
I subtracted the x and then I got 11.
Cool. And then if I plug in Emma's answer, x plus 1 becomes 11 plus 1, which is 12. And then 2 times 11 is 22. And 10 plus 20, or 10 plus 12 is going to give you 22. So nice job. Okay, cool. All right, number 13. Who did 13 for us? Jillian. All right, Jillian, we need to find the length of ED. So they give you x plus 3, give you x plus 2, they give you 13. What was the equation you set up?
X plus 3 plus x plus 2 equals 13.
Cool. Combine like terms after that. Subtract 5. What'd you get as final answer? Cool. But you need to find what ED is, which is?
7.
Good job. Plug it in, and it gives you 7. Great. Any questions on your worksheet? This is a practice that I would like to adopt where I put numbers on the board. You guys roll on in, get your homework out. If you know how to do it, put the problems up on the board. Cool? Great. That way you don't have to listen to me talk the whole time. Jillian, what's up?
Yeah, number 7.
You want me to go through it? Number 7? Okay.
I don't know, I just didn't get any of those right with like the...
Well, let me look at what you did.
I don't honestly know what I did.
Okay.
I think I just did it completely wrong.
You put your midpoint there, and then did you initially...
I had -8 and 15.
Okay, but you initially put that value there, right? So then if you do, what was your... difference from 8 to 1?
Oh, I think I did it just these and then these.
I think you did it. Yeah, I think you're right. So you need to look at like what's the difference? How do I get from 8 to 1? What do I need to do? I need to subtract 7. And then how do I get from -7 to -6? I would need to add 1. So I think you just did the opposite values.
Yeah.
You just did opposite in your head. That's all. And then you do the same thing here. So if your midpoint is 6, 2 and your endpoint is 2, 3, how do I get from 2 to 6? I would have to add 4. And then if I add 4 to 6, I get 10. Does that make more sense?
Yeah.
Okay, super. All right, any other questions on the homework? All right, pull that file back up from yesterday, please. I don't know if did Miss Grissom have it as 1, 2, 1, 3 as one numbers file? If you don't have access to that file anymore, then just go to Google Classroom and it should be the 1, 2, 1, 3 numbers that you would use. If you have trouble opening it up, let me know. Are you good? Okay, we're going to start today with a throwback. Throwback Friday. In middle school, the theorem that probably stood out most in math class was Pythagorean theorem. Would you agree? That's like the only theorem you guys really learn in like middle school math. When you work with Pythagorean theorem, what shape are you working with? Yeah, specifically what kind of triangle? A right triangle. So a right angled triangle, right? So what does Pythagorean theorem do? Like, what does it relate? Like, what are you working with the right triangle? What part of it? The hypotenuse relates to the other sides, right? So when you do Pythagorean theorem, you're relating the side lengths to each other. And you usually use the letters like A, B, and C, right? And your hypotenuse was represented by which of those letters? C. So the Pythagorean theorem was, if you have 3 lengths of a right triangle, you can say that they hold the relationship of, I got the lasso out, hold on. A squared plus B squared equals C squared, where C represents your hypotenuse, okay? Now, the next concept we're going to roll into is distance. So finding the distance between 2 points. You can actually use the Pythagorean theorem to find the distance between 2 points. Let me show you how to do that. Now, I know you guys have worked with distance in Algebra 1, and you probably also did it in middle school as well too. But let me show you how to use Pythagorean theorem to do it. So it says find the distance between E and F using the Pythagorean theorem. So they tell us E is -4, 1. So I'm going to graph it. So I'm going to start by graphing E, so -4, 1. That's E. And then F is 3, -1. So 3, -1 is right down there. Okay? So somehow what I need to do is I need to find the distance between these 2 points. I'm going to use my ID badge to draw a straight line. That's some forward thinking right there. Oh yeah, that's a good line. Okay, so I need to find the distance between E and F. How the heck am I going to use Pythagorean theorem to do that? I don't see a triangle anywhere. Carter's got like 67% of a thought together. He's trying to have it finish loading so he can. He's buffering. It's almost there. I can tell it's almost there. Well, I'll help you out, Carter. Pythagorean theorem uses what shape?
Triangle.
So I need to make a triangle out of what's there. What does that look like of your triangle?
Side.
A side. Which side specifically? C, or your hypotenuse, right? So we could probably make that a hypotenuse, right? So where could I put an A and a B on that picture? You can phone a friend if you need to.
You're Raphael.
I don't know. On the sides.
On the sides. Okay, so like where would I do that though? Like what would be the sides?
Bottom.
So like down and over?
Yeah.
Is that what you're thinking? Okay. So like down and then, I went down a little too far. Sorry, I just got a little ambitious there. And then over. There we go. Okay. Okay. And then it makes a right triangle, right? And then that length becomes the hypotenuse of my right triangle. Okay, so we can label this as A, we can label this as B if we wanted to do that. Now, what would be the length of A? How far did I go down?
2.
Good. And then what about B? I got to count points for that one. 7? Okay. All right, so then how am I going to find what the length of my hypotenuse is?
You plus b squared. So you square them and add them together.
So 2 squared plus 7 squared equals c squared?
Yeah.
Nice. You guys remember your squares?
Yeah, it's 4 plus 49.
Equals c squared. What is 4 plus 49?
32.
Get out of here with that. It's 53. Equals c squared. Now, in order to solve for c, the length of that side, what would I need to do? Good. Take square root of both sides. Is 53 a perfect square?
No.
No. Let's see. The closest perfect square to 53 would be 49. So 53 is a little larger than that. So like 7.28 would be my guess if we plug that into a calculator. Okay. On your state test, you can either write it as a decimal or you can write it as a square root. Either one is fine. Whatever you're more comfortable with. Okay. All right, so we can leave it as the square root of 53, or if we wanted to get crazy, we could find out what that decimal
It's
is.
7.28.
Is it really?
Yeah.
Swish.
Have calculator open in the background.
Huh? Dang it, he got me. All right, now what we want to do is let's do it using actual distance formula. Because you guys have learned distance formula in the past. That's something that you guys have seen, right? Okay, so find the distance on a coordinate plane. So distance formula, if A is your coordinate point, x1, y1, and B is x2, y2, are points in a coordinate plane, then the distance between A and B is given by this distance formula right here. You guys have seen this before, yeah? Absolutely, you have. It is something that I do expect you to memorize. You're going to have it memorized for your quiz, okay? So square root of quantity x2 minus x1 squared plus y2 minus y1 squared. Okay. All right, so we want to find the distance between those coordinate points now using the distance formula. You guys know that I like to label things, so I would start by labeling it as x1, y1, and x2, y2. Which of these coordinate points is further left? E or F?
E.
Yes, because your x value is -4. And your x value of your other one is 3, so 3 is obviously to the right. So I'm going to say this is x1, y1, x2, y2. Okay, let's plug it into our distance formula. So EF equals square root of, distance formula is not hard, but it's a little annoying, right? Because you got to like be careful with the signs and putting everything in the right place. So it's kind of painful. All right, so x2 minus x1 would be 3 minus -4 squared plus y2 minus y1, which would be -1 minus 1 squared. All right, 3 minus -4. Hold on, I'll take a second while you guys are writing this down.
-7.
Close.
-1.
Less close.
How's that wrong?
What is minus a negative? What does that turn into? Plus. So 3 minus -4 is really 3 plus 4. So instead of -7, it'd be +7. Yep. Yeah, you did. So 7 squared, I'm going to leave the parentheses there, plus, all right, -1 minus 1? -2. You guys do okay with negatives, or are they a little tricky? They're tricky at times, right? Just got to be careful. So if you're at -1 on the number line and you go further left to the negative, then you get -2 squared. Okay. 7 squared. -2 squared. Yes, it is not -4. It's 4. When you square a negative number, it becomes positive. 49 plus 4? Square root of 53. So that's a good answer, or 7.28, which Carter checked for us. Okay? Questions there? We feeling all right? That should be a review. You guys should have done distance formula before. Okay. All right. let's do a couple of examples. Find the distance between A and B using the Pythagorean theorem and the distance formula. So they want you to do both methods here. What do they not give you? They don't give you the formula, so we could do that. AB, let me write that at the top of the slide, equals square root of x2 minus x1 squared plus y2 minus y1 squared. And then, so that'll help us for the distance formula part. But what about Pythagorean theorem? What did they not give you for that? They didn't give you like the points on a graph, right? They gave us what the coordinate points are, but they didn't give us a graph. Could we copy this? We do a little bit of copy pasta and then paste. Oh my gosh, guys, we're so smart and resourceful. Look at that. That's pretty cool. All right. Do you guys want to take a second and try this on your own? Or do you need me to hold your hand for this one? Try it on your own? Try it on your own. You can do it. I believe in you. Yeah. Oh, man, this graph ain't good for us, though. Why? It doesn't go to 10. Womp womp. All right, we thought we were slick. I'll help you guys with the graph. So do distance formula part first. Do that part first. Do that right now. And then we'll check in with each other in a minute. Yesterday we did midpoint stuff, and you saw when we went over it on, it's pretty simple stuff. So what I would advocate for is for you to watch the lecture.
Okay.
And then just take the notes on the numbers file. And then if you have any questions, you just let me know. We got to get you a stylus, buddy.
I know, ordered one.
Did you really? Nice. When you do this, minus a negative is going to turn into a plus. So negative 10 plus 7 would be negative 3 instead of 17. You all right? Okay. Four squared is 16. It's okay. You're a human being. We're just getting started.
I know, I'm just trying.
The graph part.
I'm trying. Well, we would do 2 minus 6, right? Because.
Yeah, either 2 minus 6 or 6 minus 2.
If we did it negative 10 minus negative 7, we do that.
Yes,
Okay.
yes. Then you got to keep it consistent. You're right about that. You're right? Okay. Did we figure out our addition woes?
No, I don't think this is right.
So negative 7 minus negative 10. Minus a negative turns into a plus. So it'd be like negative 7 plus 10, which is 3. 3 squared will give us 9. And then 6 minus 2 is 4. So 4 squared is 16. You're almost there, though. And then remember to keep all this stuff in a square root. How you doing?
Good. Is this right?
What happened here? 9 and 16 is 25. Goofball.
And
Nope. Negative 7 minus 10. Someone knocking on my door?
yeah, it's 3.
Yeah. What's 3 squared? Hey.
Yeah, I got thinking.
All right. Let's do the distance formula part first, and we'll do the graph together. Okay. Okay, so I'm going to go through and label, because again, it just makes it easier for me. X1, Y1, x2, y2. Okay, and then what I want to do is toss that into the distance formula. I saw a lot of good stuff when I walked around, so I feel like we're ready to review. Okay, so AB equals square root of, okay, so I'm going to do x2 minus x1. So that looks like -7 minus -10. And I heard a lot of really healthy conversations about what that is going to equal. Plus, and then let's do the y values. So we did -7 first, right? So I'm going to do 6 minus 2. Okay. Now, if you did -10 minus -7, that's fine. You have to do then 2 minus 6 because you got to keep it consistent in the order of the points that you pick from. Okay, so let's have a real conversation about this. And I know it's annoying, but you got to write it inside of a square root each time. How do I figure out -7 minus -10? What's your mindset with that? -7 minus -10, what's that going to be? Alex?
Normally I just think of if there's two negatives next to each other, you get rid of it and turn it into a plus.
Yeah, so like the minus the negative part you're talking about? Mm-hmm. Okay, so then this is like -7 plus 10. Mm-hmm. So what's that going to be?
3.
Yeah. So you have more of the positive values there, and so you would end up with a +3. So then 3 squared, good. All right, and then 6 minus 2? That's easy money. 4 squared. Okay. So then what's 3 squared?
9,
Yes. 4 squared? 9 and 16?
25.
That's a perfect square. What is it?
5.
Yeah, so we get an answer of 5. All right, cool. All right, you ready for a little bit of a throwback when we do the Pythagorean theorem? It's kind of annoying to graph this. So since it didn't fit on the scale of the graph that I originally pasted in there, let's be crafty about how we graph this. My x values go from -10 to -7, which means I don't really care about the right side of my graph, right? And then my y values are all positive, so from 2 to 6. So I would just put a little graph that looks like something like that, right? Because I really care about what's happening in this area of the graph, okay? So then I would do -10, so I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So then that's -10, and then 9, 8, 7, so -7 we're going to use. And then my y values are 2 to 6, so 1, 2, 3, 4, 5, 6. Is this the most accurate graph you've ever seen in your life? No, it is not, but that's all right. We just got to be careful about how we count our points. We should be all right. All right, so -210 is going to be like right over chair. And then let's see, -7, 6 is like right over chair. So then, boom. Okay. So then we need to put the side lengths of our triangle in our graph, right? So I would say we go down, whatever, this many and over that many. How far do I go over to get from -10 to -7? How many units is that? 3. So I'm going to put a 3 here. And then to get from 2 to 6, how many units is that? 4. All right. What type of triangle is this? Anybody remember? What? It is a right triangle. Do you guys remember studying 3, 4, 5 triangles? Have you ever seen those before? Okay. All right. Well, you're going to see it right now. So we need to use Pythagorean theorem, right? And the side lengths are 3 and 4. So if we do this, we get 3 squared plus 4 squared equals c squared, yeah? What's 3 squared?
9,
4 squared
16.
equals c squared. So then I need to take the square root, right? 9 plus 16 is 25. So it's going to be 5, okay? Which means my hypotenuse was a length of 5. And that's why it's called a 3, 4, 5 triangle, okay? Oftentimes when you do square roots, it's possible that you end up with decimals, right? Like we took the square root of 53 earlier and it was 7.28. When you have a set of 3 numbers that work with the Pythagorean theorem and they're all integers, meaning they're all whole numbers, we call those Pythagorean triples. 3, 4, 5 is the most famous Pythagorean triple. There's also like 5, 12, and 13, 7, 24, 25. There's a bunch of them out there. 8, 40, and 41. But either way, yeah. Okay, questions there? All right. We're going to do another example. But you guys are going to do it by yourself. And it says by using both the distance formula, and then it doesn't go on to say and the Pythagorean theorem. So just do it using the distance formula. So do distance formula with this one real quick, please, and thank you. This would be 3 plus 2, which is 5. And then your other ones, hold on. Your other ones are 4 and negative 2, which is 6. All right, so that's good. That other one's good. We got to get you a stylus too. Where did that 7 come from?
Oh, wait, yeah, I was doing the math.
Nice. Doing
What are we
okay?
always supposed to do? Put A, B? Or was that for the...
It is. It's just whatever letters there are.
Okay.
So you do CD. You forgot the squares. So you would do 3 minus negative 2, which is 5 squared.
Mm-hmm.
So like here, when you do the numbers in there, you gotta remember that they're squared. So once you find that difference, you have to square it to end up with the number before you put it in the square root. It's honestly like best if you leave that formula like in front of you. There you go. Yeah, look at you. Square root 61. Oh yeah. That looks good, Haley. I like the colors you picked.
It's random. It changes every like 2 minutes.
There's nothing wrong with that. When you negative 2. So if you choose this number first, it's minus between the two. So it'd be negative 2 minus 3. So then this one would be, you got to keep the order the same. So then this would be negative 2 minus 4. Good job, Kens. What was that? All right, that looks good. Good job. Getting there.
I
What's
did
up?
the formula wrong, so I had to redo it.
Yeah, okay. Don't forget the squares. That's on there as well too. Good job, Emma. That looks good, Parker. Kalia, that's perfect. How'd you do? Awesome. 61, not 51.
Oh, that's what it is.
Okay. We ready? I saw a lot of good stuff walking around. Okay. I'm going to label it X1, Y1, X2, Y2. So a couple things. If you're having most of you guys did really good. if you're having difficulty making sure you're plugging in the numbers the right way, I would start by labeling the points. So like I labeled that as x1, y1, x2, y2, and then that'll tell you exactly where in your formula to plug them in. Carter, what's up?
For the X, Y, and Y1, would those always be like whatever, since it's C, would that always be X1 and Y1? And
So like C becomes before D in the alphabet. Is that what you're talking about? So like C, can we automatically label it as X1, Y1? A couple things go into it. This is like nerdy math extra teacher stuff. I look at which X value is furthest to the left. Whichever one is furthest to the left, that's the one I label as X1, Y1. But I'll put it this way. As long as you are consistent with like how you pick your numbers, it doesn't matter. So like when it comes time to put them into my formula here, I'm going to do, the difference of two numbers squared, difference of two numbers squared. So like, as long as I choose the order the same each time, then I'm fine. Like if I do, like I would do x2 minus x1, so 3 minus -2. But I could also do -2 minus 3, and as long as I'm consistent, I should still get the same answer, okay? So then if I did -2 minus 3, I would have to do -2 minus 4 for the next one, okay? Most of you guys did it different than that, which is I did it the way that you guys would do it as well too, which is fine. I just want to illustrate the point that as long as you're consistent, you get the same answer. So in my case, like you guys probably did like 3 minus -2, right? Which is 3 plus 2, which is 5. In my case, I would do -2 minus 3, which is -5. So -5. But when you square it, it takes away the negative and you end up with the same answer anyway. And then plus -2 minus 4 is -6 squared. You guys did this part the same. 5 squared is what?
25.
Yeah, -5 is going to be the same thing. And then -6 squared would be,
36.
good. And what's 25 plus 36? Great. Okay. That's just shy of 64. So it's like 7.89. I don't know what that one is. Anybody check it? What is the square root of 61? 7.8. What's after the 8?
1.
Dang it. 7.81. I thought it was 7.89. I was close, though. All right. Any questions there? Pull out your worksheet. From yesterday, the one that we went over. You probably need a copy, don't you, Brio? Cassidy, I gave you a copy, right? This is my last one. All right. Guess what you're going to do? Yep. But we're going to do them right now.
That's not homework?
Nope, we're going to do it right now. That way we'll go home with no homework.
Oh.
So, we're going to do it on the board, though. I need a volunteer to do number 1. You're just doing distance formula between 2 points. Carter's doing number 1. Who's going to do number 2? Parker's doing number 2. Who's going to do number 3? And I'll check it before you go up on the board. Let's get some people that didn't go up the first time around. Right. Nice. Number 4. Who's going to do number 4? I don't really care if you went up the first time around or not. Who wants to do number 4 for me? Alex. And then what was the last one? 14? Who could do, which I think is like predominantly the same thing. Parker, you're already doing one, my friend. Who can do 14 for me? Do you want to swap out? You want to do 14 instead, Parker?
No.
Okay, who wants to do 14 for me? Emma. Okay. All right. If you want, take a minute to do it at your seat, and then when you feel comfortable, just go up and do it. You guys will have to erase whatever's on the board. But, yeah. So we'll do it on the board, and then we'll go over it. And then that way, you guys don't have homework this weekend. That's my gift to you. Long weekend, no math homework. Don't get used to it, though. Just me being nice.
This right.
Sorry. It's perfect. Good job. And just erase wherever you're at, Raph.
there's no letters, should we just put like D for like distance?
Sure, that's perfect. I think it's a great idea. It would be 2 minus 5.
Oh yeah, I keep on doing like math in my head and
That's where it gets you when you do that math in your head. That's where it gets you. Will you do me a favor, Raph? Will you erase everything that's around it that... Yeah, that way we can just focus on those. What'd you do, number 2?
Yeah.
Is that the one I told you to do was number 2?
Yeah.
No, I did number 2.
Raph did number 2.
you told him to do number 2.
I told Parker to do number
Yeah.
2.
He's in 3.
Raph was supposed to do 3. Your answer for 2 is really good. But will you do number 3 for me? Thanks, Parker.
It's just,
I don't know.
it's kind of messy.
I don't judge. How could I possibly judge? So that's a 9. It's got to be positive 9.
Yeah, positive 9.
Okay.
16. It's 25 square root of 25 is 5.
Negative 1 minus negative 3.
Is that not negative 4?
No, because it'd be negative 1, and then there should be a subtraction sign, and then that would go with the 3, because the 3 is negative
So
there.
would it be 2?
Yes.
2.
Yeah. Yo. Which one did you do?
4.
I like it.
Alright.
Final edition?
Square root of 13.
I don't know. I don't
I didn't
remember what the
change
answers
it.
are. I'm pretty sure that's right.
I said plus 4.
Yeah.
Is it plus 4 or plus 2?
So like, sorry, stop your foot there. Let me see your pencil. So like when you do it, it would be, because I want you to show your work on the board. It's negative 1 minus negative 3, which turns into negative 1 plus 3.
Oh, so it'd be 2.
So it's positive
So
2.
it's
2
square root
squared
of
is
11.
4.
So, oh yeah, no, I was right. So it is
Yeah.
square root of 13. Alright.
Yeah. Just when you put it on the board, go slow. Make sure you're showing your steps and everything looks good. That's good. That's good. Good job, bud. Emma. You did 14?
Yeah. Which way? Reading the graph? I did both, but
Ooh. Good job. So then you found your step from here to there was, for X's it's 5, and then for Y's it is 7. Nice. That's perfect. Great job.
do I put it up there?
Anywhere you want. I would probably just do it in the back. That way you have enough room. And then just erase whatever else is on that board, Emma. Or just like start writing and I'll erase the other stuff. What up? It's perfect. Good job. What, this is for now? Yeah, hustle. I should have made Carter explain his question before he went to the bathroom. I messed up. I'm just going to explain it for him. All right, Carter, what'd you do for number 1? Well, I put the points on the board. No, I'm just kidding. Let's see. So Carter has 2, -1, and then 5, -3. So then he puts it into the distance formula, and he does 2 minus 5, quantity squared, and then plus -1. So he did, this direction here. So he's going to do -1 minus -3, and then quantity squared. Okay, so 2 minus 5 is -3. And so he does -3 squared to get 9. And then here, -1 minus -3 would be like -1 plus 3, which is +2. So then 2 squared is going to give him 4. So this says his 9s and 4s look alike, just like mine. So 9 plus 4 is going to give him 13, so square root of 13 is his answer. Oh, Raph, since you're up here, that's perfect. Go ahead and walk us through what you did for number 2 while you're up here.
-6 plus 4, square root 4.
Okay.
6 minus 4, square root 4. Add this together, square root of 8.
Cool. So when you did yours, Raph, you did yours in a weird order, but you still did it right. You did your y2 minus y1, and then actually did y1 minus y2 plus x1 minus x2, which is fine. We go open that. Parker's got me, okay. Which is fine. You just have to be consistent. You still ended up with the same answer.
Yes, I did.
Yeah. Cool. All right. Good job. So you guys probably did it in a different order, which is good. But Raph's answer is fine as well, too. So I guess I should talk about that. So like, in your distance formula, you do the difference of your x's squared plus the difference of your y squared. Since you can add in either order, technically you could do the y's first, okay? All right, who did number 3? Parker, that was you, right? Okay, so we have -6, 2, -8, 5. Tell us what you did, Parker.
A label.
Proud of you for that.
Yeah.
Good job.
AB equals square root of -8 plus 6 squared plus -5 minus 2 squared.
Cool. Because the minus negative, that's how you got the +6 for that first one, right? Okay.
And then AB, I simplified, AB equals square root of -2 squared plus -7 squared. Simplified again, AB equals square root of 4 plus 49, which goes out to AB equals square root of 53.
Good. Good job. I like how you kept your parentheses intact and your negatives were inside of the parentheses. That was a really clean way of writing it. So you did good. Good job. All right, number 4. Who did number 4? All right, Alex. What is that? 3, 1, and then 6, -7. Tell us what you did.
So put 6 minus 3 square root of 6 squared, parentheses plus
Yeah, keep going.
-7 minus 1 squared, and then simplified it, simplified again, and to get 9 plus 64 squared, and then answer was 73 squared.
Perfect. Good job. I like it. All right. Emma put some work in back there. Emma drew a graph for us, and we were doing the distance between those 2 points that made up the hypothesis. Hypotenuse. Oh my God, sorry. Wrong class there for a second. So our hypotenuse, Emma put that up there, and then she drew the lines for the triangle. That looks really good. So what did you find your differences were for your x's and your y's?
7 and 5.
Nice. So then Pythagorean theorem with 5 and 7. So 5 squared plus 7 squared gave you 74. So then you ended up with square root of 74. Now, if any of you did the distance formula, you get basically the same thing, right? You would do the difference between those values, and square root of 74 is what your answer would be. Okay. Questions there? Hey, look at that. You guys did your homework for the weekend. Nice. All right, cool. If we had more than 4 minutes left, we would do a round of questions. But we don't have time. It usually takes like 8 minutes to get through a whole thing. So we'll do it next week. All right. Rest, recover after your first week. We'll get after it on Tuesday. Okay? Enjoy your weekend, guys.